All right, everybody. Friday, I'm not going to be here today, and I imagine that there's some of you coming in saying I have no idea how to do this. So I am going to go through the Hess's Law homework. This is what we were going to do on Thursday, and we had the ice day. So, anyways, I'm going to go through these 5. Please just watch, make corrections, or check your work depending on how well you did on this. I'm going to cut right to the chase. Remember, this is the sheet you have, Hess's Law notes. And the 2 rules to live by are right here at the top. So this is where we want to end up here on number 1. We want to finish with this equation. So this is kind of like a system of equations in the algebra class. You're just trying to get things moved around and canceled. So I look at the overall equation. I need hydrogen peroxide, H2O2. I need 1 of it, and I need it to be on the product side. So H2O2 shows up here in reaction A. I have the correct amount. I have 1, but it's on the wrong side. So what I need to do is take reaction A and flip it. Okay, so I'm going to rewrite that down here. Reaction A is going to become H2O liquid plus 1/2 O2. That would be a gas, even though it's not written right here, missing. And then my hydrogen peroxide, H2O2, becomes a product. Okay, so I just flipped that around, so I got the H2O2 on the correct side. When I flip the equation, I need to take my enthalpy change, delta H, and make it now positive 98.0 kilojoules. When you switch both sides of the equation, you have to reverse the sign of delta H. Okay, so I'm good with that. Now my A is right here, so I can check off H2O2. It's correct. Okay. Now I'm going to come over here, and I just arbitrarily started with H2O2. You can start with anything you want. H2 gas, I need 1 of it, and I need it to be on the reactant side. So I'm looking, it wasn't in reactant A, no H2 there. Here's H2 in reaction B, and it's on the correct side. It's a reactant, just like I need. But I have 2 of it here, and I need to have 1 of it. Okay, so what I'm essentially going to do is take this entire reaction B, and I'm going to multiply everything by 1/2, including the enthalpy change, delta H. So I'm going to rewrite B. 1/2 times 2 just gives me 1 H2 gas. 1/2 times 1 O2, now I have 1/2 O2 gas. And this yields 1/2 times 2, so 1 H2O as a liquid. And then, again, my delta H stays negative because I didn't flip the equation, so it's now negative. And then half of 571.6 equals negative 285.8 kilojoules. All right, so now at this point, I'm just going to kind of check my work and make sure everything's where I want. I have 1 H2 on the reactant side. I need 1 O2. Now, I didn't do anything with O2. Well, since O2 appeared in both half reactions, I just left it alone, and it worked itself out because since these are on the same side, they're both reactants, I can add them. Basically, what we're doing is we're adding these. So the H2 gas falls down. I have 1 O2 gas. Now, when those halves combine, I have an H2O liquid on the reactant side and an H2O liquid on the product side. So those are going to cancel out. So the only thing on the product side is my 1 H2O liquid, which is what I wanted. Okay, so now my reactions yield exactly what I wanted to end up with. Since that works, all we're going to do is add our 2 enthalpy changes. So using the calculator, I've got negative 285.8 plus 98.0, and we get negative 187.8 for our enthalpy change. Negative 187.8 kilojoules. And that would be your answer. Okay, that's all I want. Calculate the enthalpy change delta H for the reaction. Did that, you could say this reaction is exothermic because delta H is negative, and you're finished with that problem.